Assalamu alaikum. I hope you all are fine. Today we are starting chapter number 3, exercise 3.1 of grade 9 Federal Board. Before starting exercise, please like and subscribe my channel for more videos. Question number 1 is shade A union B intersection C, A intersection B union C, A union B union C, and A intersection B intersection C using following Venn diagrams. So here four Venn diagrams are given, so we have to solve one by one and apply the four operations on each Venn diagram. So first we start with first Venn diagram and apply all the four operations on it one by one. Question number 1 is the shading of four operation on a given Venn diagram. So we have to apply all the four operation on the single Venn diagrams. The first one is A union B intersection C. So first we will shade the area B intersection C in given Venn diagram. B intersection C is a common part of B and C. So we will shade it with the horizontal lines like this. Horizontal lines. So we will represent B intersection C equals to a box with the horizontal lines. So A union B intersection C equal to all part of A and the intersection part of B intersection C. Here we will shade A with the vertical lines. So the total shaded area for the given operation is both vertical and the horizontal line area. Vertical and the horizontal line shaded area is the given shaded part of the question, that is A union B intersection C. So we will represent the final shading with the vertical and the horizontal lines. Second one is A intersection B union C. So here first we represent the shaded area B union C. B union C mean all the area of B and C should be shaded. So we shaded it with the horizontal lines like this. We draw the horizontal lines on B and C. Now A intersection B union C. B union C is equal to horizontal lines that we represent it, and A intersection B union C, common part between A and that shaded part. As a common part between A and that shaded part is that part. I can highlight it. This part is the common part between A and B union C, so I highlighted it with the vertical lines and this. So A intersection B union C is represented by double lines, as you can see in the diagram. This part is A intersection B union C. Third part is A union B and union C. A union B means all part of A and B are shaded, so we shaded it with the vertical lines A and B. Shaded A and B with the vertical lines. So here we will represent the shading of A union B as vertical lines. Now A union B union C is equals to mean all parts should be shaded of A, B and C. So we will shade C with vertical lines too. So this all vertical area represent the shading of A union B union C. We can shade diagram C with vertical or horizontal line, it's your choice. So these vertical and the horizontal line represent the shading of A union B union C, all vertical and the horizontal line. Part 4 is A intersection B intersection C. So first we will shade B intersection C part, which is a common part between B and C, and represent it with the horizontal lines and write it as this: A intersection B intersection C. As there is no common part between the shaded area and the diagram A, we can represent it with vertical lines. So you can see that there is no common part between vertical and the horizontal lines, so there is no shading of the given operations, and we will set that A intersection B intersection C equals. So in second Venn diagram, we apply all the four operations. First operation is A union B intersection C. So first we shade B intersection C part with the horizontal line. B and C part and shaded A with the vertical lines. A union B intersection C mean all the vertical and the horizontal shaded area is included. So A union B intersection C equals to all horizontal vertical lines and the horizontal line area. Second operation is A intersection B union C. So first we shade B union C. B union C mean all part of B and C with the vertical lines. A intersection B union C. We shaded A part with the horizontal lines. So we have to select the part which is common between A and B union C. A, as A is a subset of C, so the common part between A and B union C is A part where double lines are shaded. So the only part we selected here is double line part. Which is the answer. So A union B equals to all part of A and B. We shaded it with the horizontal lines. A union B union C. It means we have to shade all part of A, B and C. Union mean all part is shaded. So we already shaded A and B. Now shade C with the same horizontal lines. So the required answer is all the shaded part with horizontal lines, all part of the Venn diagram ABC. In last part we have to first shade B intersection C, which is mean B and C common part, which is this with the horizontal lines. Now shaded A with the different lines, vertical lines. A intersection B intersection C mean we have to choose and shade the common part of A and this part of vertical and horizontal, as there is no common part between vertical line and the horizontal line, so we say that A intersection B intersection C equals to phi set, no shading. Third Venn diagram is this, in which we have to apply all the four operation. Operation number one is A union B intersection C. So first we have to shade B intersection C part, common part between B and C. So the common part between B and C is this part. We shaded it with the dots. So we shaded B intersection C part with dots. So A union B intersection C part is all part of A and this. So we shaded A part with horizontal lines. A union B intersection C is the all part with the horizontal line and dotted part. In second operation, first we have to shade B union C, which is all part of B and C. So we shaded it with the horizontal line B and C. And we shaded A with vertical lines. So the common part between A and B union C equals to A intersection B union C. So this is the common part. Which represent A intersection B union C. So all the part with boxes is the shading of A intersection B union C. Third part is the shading of A union B union C. It means that A union B equals to all shading of A and B with the horizontal line. And union C mean all part of C. So it means all part of A, B and C is shaded and is the required answer. So here A union B union C equals to all the shaded part with the horizontal lines. Last part is, first we have to shade the A B intersection part, which is a common part between B and C. So common part between B and C is this part. We shaded it with the horizontal line. And shaded A with vertical lines. So the common part between A intersection and B intersection C is, common part is this area. So this represent A intersection B intersection C. So all we shaded B intersection C with the horizontal line, and the shaded area between A intersection and B intersection C is the box area. So last Venn diagram of question number 1 is this, and we have to apply all the 4 operation. One is A union B intersection C. So the shaded part of B intersection C, as B and C have no overlapping part and they are different, no common part, so B intersection C is equals to phi set, and A union B intersection C mean all part of B intersection C and A. So B intersection C is phi set, and union of phi and A is equal to A. So we shaded all part of A with the vertical lines. So the answer is all part shaded with vertical lines. In B operation, there is A intersection B union C. So first B union C, it means all the part of B and C, all part of B and C. So first we shaded all part of B and C with horizontal line. And A intersection B union C. So here we shaded A differently with vertical lines. So A intersection B union C is equal to that part of the diagram, which equals to A intersection B union C. So shaded part is double lines. Now third operation is A union B. So A union B equals to all parts shaded of A and B with the vertical lines. A union B and union C. Here we shaded C with also vertical lines. A union B union C mean all part of A, B and C are shaded. So the required answer is all the shaded part with vertical lines. And in last part, first we have to shade B intersection C part, as there is no common part between B and C, so it is phi set, and intersection of A with B intersection C is intersection of A with B intersection. So intersection of A is only with B, not with C. So B intersection C part is phi, and intersection common part of A and phi is also phi set. So there is no shading.